Hi, ladies and gentlemen. Today we're going to be continuing our lesson with radicals. So far, if you remember, we've learned to simplify, add and subtract, and multiply radicals. So now we're down to our last operation, which would be to divide radicals. And we're also going to be talking about something called rationalizing them. And we'll get more into what that means when we get to it, okay? So here we go, dividing radicals. I've got a couple notes for you. All right, division with radicals. Just like in multiplication, how you can take a radical and split it up using multiplication. Here, I'll give you an example at the top here. Square root of 50, radical 50. You guys know that you can split this into radical 25 times the radical 2. 25 times 2 makes 50. Well, I can do the same thing, this idea of splitting, but with division, all right? But in algebra, we don't write division using that old division symbol like this division symbol. Instead, we write division using fractions. So see here inside this radical, we have a fraction, and that really means a divided by b. Well, instead of leaving a fraction inside a radical, I can take it and split it into two radicals, one on top and then one on the bottom. That way I can simplify each one separately. All right, there's two things you have to know about radicals before we move on from here. First one, you cannot have a fraction inside of a radical, which is why we have this property here, which allows us to split it up into two separate radicals. Okay, so you cannot have a radical inside a fraction. And then the last rule is you cannot leave a radical in the denominator. Right? And if you don't remember what a denominator is, that's the bottom of a fraction, right? So here I'll make a note. The denominator is the bottom of a fraction, okay? So we can't have a radical in the denominator. All right, so let's take a look at some examples, and then maybe you guys can see what we're all talking about here. Okay, so our first example, let me just bring this up to the top. All right, first example. 9 over 16. So the square root of 9 over 16. So remember, I can take this and I can split this up into a top and a bottom, a numerator and a denominator. And now I can look to simplify each one. In fact, the square root of 9, we know what that is. That's just 3. And the square root of 16, we know what that is as well. That's just 4. And there we go. No more radicals because both of these numbers, 9 and 16, were perfect squares. So there it is, 3/4. All right, number 2. Check this out. We have a square root of 5 over 81. Again, I'm going to take this and I'm going to rewrite this, right? I have a radical 5 on top and a radical 81. I just split them into individual top and bottom. Now from here, I notice that square root of 81 right here, this can be simplified. That's a perfect square. I know this is just 9. Now on the top there, square root of 5, we cannot simplify that any further, so that just stays. And let me just check my two rules at the top. The first rule, it says you cannot have a fraction inside of a radical. Well, when I look down at my answer here, the square root of 5, that's not a fraction, so I haven't broken that rule. And my other rule is you cannot leave a radical in the denominator. Well, let me see. My denominator is a whole number 9. There's no radical. So again, I haven't broken any rules, so we are good to go. This is as simplified as that expression gets. All right, let's take a look at another two examples. 15 over 12. All right, so I noticed something here. Before I even begin 15 and 12, I can reduce this fraction. It's a fraction, right? So I can reduce this using my normal rules of fractions that you guys know. 15 and 12, let's reduce that by 3. So if I divide that by 3, let's think about what we have. This is 5 over 4. Notice how it's still inside the radical because we have not used up that action of square rooting anything yet. So now I can apply my rules of radicals and split the top and the bottom. Square root of 5, square root of 4, and take a look. Square root of 4, that's a perfect square number. The square root of 4 is 2, so this all simplifies into the square root of 5 over the whole number 2. And again, checking my rules, I do not have a fraction inside of a radical, and I do not have a radical in the bottom, in the denominator. So it brings me to this important note here. Notice how we can reduce, right? Look at how we can take a fraction and reduce something. As long as you keep in mind that you can only reduce insides with insides and outsides with outsides. Kind of like our rule with multiplication. Here, let me take a look at example number 4 for you so you guys can get a feel for what I'm talking about, right? When I reduce, you can only reduce insides together and outsides together. So insides with insides, outsides with outsides, do not mix and match, right? Insides go together, outsides go together. So in this case, when I take a look, hey, I can reduce 4 and 6. If I reduce that by 2, don't I end up with 2/3? And then separately, I notice that I can reduce 6 and 8, but those are inside the square root. So when I do this, I reduce 6 and 8 into 3 and 4. So again, reducing, you can still reduce your fractions as long as you do not mix insides with outsides. Okay, from here though, look, I can simplify. Look at this, square root of 4. The square root of 4 is just 2, so I know that this on the bottom here will be 3 times 2. At the top, there's nothing I can do with that, so I'll just leave it. Bring it over. And take a look. 3 times 2, again, that's 6. And normally I would stop here, but hey, I can reduce. Check that out. 2 and 6, and they're both outside of the radical. I can reduce these. I cannot, let me go back here. I cannot reduce 3 and 6 because one's inside a radical, one's outside of a radical. We can't do that. So it's almost like reducing things with like terms. So again, I can reduce the 2 and the 6. If you think about what that is, right, what that becomes is 1 over 6, radical 3. Do I need the 1 in front? Oh, 1 over 6. No, I mean 1 over 3. My bad. Do I need the 1 in front? No. I can leave this as just radical 3. As you guys know, 1s out in front don't really mean much. You can not have them there. You can turn them invisible. And that's it. This is as far as I can go. Again, no radical in the denominator and no fractions inside a radical. I cannot reduce these any further because, again, one's inside the radical, one's outside. And there you go. That's as simplified as it gets. So this is the first part of today's lesson. We are dividing radicals. We can split them up top and bottom, and then you're just looking to simplify from there.